Okay, so we left the end of last term looking at the production of ethanol, and we were looking in more detail at the fermentation of glucose, and we looked at how the ethanol produced this way can be used as a biofuel and whether it's carbon neutral or not, and we went through some equations. And then we briefly looked at the generation, the industrial production of ethanol, which is taking ethene with steam to make ethanol by this equation. And we need an acid catalyst for that reaction to work. So what we're going to look at is I just would like to look at the mechanism for that reaction, just so that we're happy with how that's going to work. So we're going to start off with our old friend ethene. Now remember, we have got an acid catalyst in this reaction. So it's actually H+, which is the first guy that gets involved. Curly arrows show the movement of electrons. So here he comes. Out come the electrons from the double bond to my hydrogen there. And that is going to mean that that carbon has now got 3 hydrogens attached, but the end carbon has lost his double bond, so now has a positive charge. But luckily, here comes my H2O, and this is of course in the form of steam. The lone pair is going to attack that carbon with the positive charge, like so. So I have this intermediate molecule where I have formed the oxygen carbon bond, but now that oxygen has got 3 bonds attached. He's not going to be a happy boy because he's now donated his lone pair to that carbon, which he's got a plus charge on him. He wants to lose that hydrogen there, so that bond breaks to give me ethanol, like so. But that hydrogen has gone, so plus H+, and you can see how the H+ is a catalyst because I've regenerated the H+ at the end of the reaction. So you need to note that mechanism.